Hello guys, welcome to my channel Techmon.in. In this particular video, we will learn about TF-IDF, which stands for Term Frequency and Inverse Document Frequency. What it is, we'll learn slowly, but what's its purpose is, it helps us to convert our textual information into numerical format. Okay, so we can use those numerical features into our any machine learning model. Okay, so this is the formula. Don't be afraid of this formula. It is very simple, and we are going to do a very short exercise to learn how to implement it. Okay, so first, TF-IDF is calculated for every term. Term means term could be a token in a sentence, or it could be a character in a word. Okay, so term could be a token or character or word. Okay, we calculate TF for it, basically term frequency, or number of times a particular word is appearing in a sentence, or number of times a particular character is appearing in a word. Okay, so that is term frequency. Then let's forget about this log part and plus 1. Let's focus on capital big N. Okay, so this big N, capital N, is the number of documents you have. So when you are training in your training data set, it is the number of records you have, or number of sentences you have, or number of tokens you have. Okay, so number of tokens, I mean, if you have character level, you are creating this at character level, calculating term frequency at character level, then capital N is a number of words you have. But if you are calculating at word level, basically your document is sentences, then capital N is number of documents. Okay, so capital N is nothing but number of records you have in data, or number of documents you have in your data. And this DI, it is the number of times a particular term is in how many documents this particular term is appearing. So let's say capital N was 5. Let's say we have total 5 sentences, and let's say a particular sentence alpha appeared in 3 sentences. So capital N is 5. This di term, I means alpha for a particular term alpha, and d will be 3, so it will be 5 by 3. Why we are doing plus 1? Because log of 0 is not defined. So for cases where our term, we can also put it like this: di plus 1. Okay, so if a particular term does not, let's say, appear in any of the sentence, but it won't be a case, we'll always have term which appeared at least in one of the document. But let's say if for some reason di is 0, log of 0 is not defined, and 0 in denominator is not defined, so it will take care of all those things. Okay, so with this, I think this is all for this. Let's implement it. So what I've done here is I've created I've kept top five programming languages here. Okay, and what we are going to do here is we are going to create the term, calculate the TF-IDF term for this. Okay, so we have our documents, kind of these words. These each programming language is a document, and what we have as term, the characters, the English alphabet letters. Okay, so let's first focus on, let me zoom on it. So let's focus on term frequency. Okay, for each of the term here. Okay, what we are going to do, we are going to put the number of time it is appearing in this particular document, which is the language. So let's start with P. So P is appearing only one time in this Python word or document. Okay, we are going to put 1 here. Y is also Y. in Python is also appearing one time, so one here. T is appearing one time, so we are going to put one. H also one. Where is it? O one and one one. Okay, so let rest of them will be 0. So let me fill them as well. Okay, 0 0 0 0. So basically, wherever we are seeing a character, we are putting 1, otherwise 0. Okay, so our term frequency has been calculated for document Python. Similarly for Java, let's start with J is appearing only one time, so 1 here. Okay, then is appearing 2 times, then 2 here. Then V is appearing 1 time, 1 here. Then rest of the values will be 0. Okay, we are going to fill 0 everywhere else. Okay, so we are done with Java. Now similarly for C everywhere is 0. It is just one character. Okay, so basically we'll fill 0 everywhere, but 1 under C here. Okay, similarly for JavaScript, J will appear only. Let me fill 0 in every place, then we can backpropagate like that. So 1 in J, A 2 times, V 1 time, similar to Java, then S 1 time, C 1 time, R 1 time, I 1 time, SCRI, P 1 time, T 1 time. Okay, so we are done with this one as well. For Scala, there are two A's, so I'm going to put 2 here. There is one C here, then L is 1 here, and then finally 1 S. Okay, so this is how we are calculating the term frequencies. Okay, also let's define somewhere like capital N. For us, capital N is 5. Why 5? Because we have 5 records in our data, or we have 5 documents. Okay, so capital N is 5 in our case. Okay, now we have, if we look at the formula, we have calculated term frequency. So here I was for basically for each of the terms. These are the terms. Okay, and these are the documents. Okay, and these are the TF values. So we have calculated TF values. Now we know about capital N. Let's look at DI term. Okay, so DI, so now the difference between TF and DI is we were calculating them row wise. Okay, so if they any term appeared in this, we were like in this document we were putting 1, but now document terms will be filled column wise. By that I mean, let's say look for A. We know A does not appear in this Python, so we'll say put 0 in term frequency. Okay, but in document frequency we look if A is appearing in any of these, basically A is appearing in how many documents. So Python does not have A, Java has A, so 1. C does not have A, JavaScript has A, 2. Scala has A, 3. So out of 5 documents, there are 3 documents where A appeared. So this will be 3. Okay, and this will remain 3 for all of them, because here we are looking across the column. In how we are not taking count of in basically what were the total A's across all the documents. No, we are just talking about in how many records or documents A appeared. Okay, so B never appeared in any of them, so we can fill this document frequency. So here it is not exactly document frequency. So inverse document frequency, so it is still just TF, document frequency. Inverse we'll take below, afterwards. Okay, so B never appeared anywhere, so 0. C appeared, if you can see here, C appeared in 3 documents, so 3. D never appeared anywhere, 0. So I'm just filling the first row, we'll copy them across all of them. Okay, E never appeared, 0. F never appeared, 0. G never appeared, 0. H appeared in one of the document. G never appeared. H appeared in one of the document. I appeared in one of the document. J appeared in 2. Okay, K never appeared. L appeared once. M never appeared. N appeared once. O appeared once. P appeared twice, once in Python and JavaScript. Q never appeared. R it appeared once. S appeared twice. T appeared twice. U appeared 0 times. B appeared twice, one in Java and another time JavaScript. W never. X never. Y once, and Z 0 times. Okay, so we are just going to copy this and put it in all of them. Okay, now we have calculated the term frequency for our features or terms, and we have calculated the document frequency. Now what we are going to do, we are finally going to calculate the TF-IDF term. Okay, now if we look at the formula for TF-IDF, what we are going to do, we are first going to take a log. Let's ignore, oh no, 0, we have zeros, so we'll have to do that. So let's write a formula to calculate this. Okay, so first let's calculate this log n, capital N by di plus 1. Okay, so first let's not put it here, let me put 5 here. Okay, bold, center. Okay, so first let's look at this formula, multiply TF. Okay, so for this we'll refer to this TF term, multiply TF. So multiply with then what it is saying, take log, any log will work. Okay, but if we take log of 10, then the values will be smaller as compared to when we take log of 2. Okay, so natural log or any log will work. So we are going to take log, then what it is saying, we have in numerator capital N, so capital N divided by, in denominator we have this document frequency which is here. Okay, then we are doing plus 1. Okay, and close the bracket. So this, these value will be smaller. Okay, since it is 0, it was not calculated at all. So let me drag the formula everywhere. Okay, I get so basically I made a mistake. I forgot to freeze this value here. So if you look at here, this 5 is getting shifted, my bad here. AC, we'll put dollar sign here and dollar sign here. Now it should be better. Okay, now what? Okay, as you can see, we have some values. Okay, let me also, before expanding this, let me calculate it again once for this particular term a of Python. Okay, so how we are doing it, So we are multiplying. First we have the term frequency. Let's do it manually. First we have term frequency, which is 0. Okay, then we are multiplying it by with log of. In numerator we have 5. Okay, in denominator we are adding 1 plus the document frequency of A, which is 3. Okay, then close and so on. Okay, so this is how we are calculating the TF-IDF term. So let me expand it again. So what it so now how TF-IDF is better than just putting these counts. First thing, 0, the lower the value is, it indicates it is less significant. Okay, so how is it so? So if you look, let's compare two characters, first H and A. Okay, H has a higher value, like it is meaning it is closer to 1.4, while A is lower, 0.19. Okay, why is it? The reason is A is appearing in more number of documents. Okay, so it is less rare, less unique or less rare. Okay, compared to H, which is appearing in only one document. Okay, so that's why it is saying, according to TF-IDF, H is more important because it is more unique than A here. Similarly, if you look at C, C is even less than. Now you will say A also appeared in three documents and C also appeared in three documents. Then why difference in their values? Second reason is C appeared in three documents, no doubt, but it appeared only one time in these three documents. Okay, while A, though yes it appeared in three documents, but in all the three documents it appeared two times. Okay, so it if we look at these values, so we say A is comparatively more important than C. Okay, so TF-IDF term is these property of TF-IDF term makes it more important. So TF-IDF term penalizes the terms which are appearing in more or more and more number of documents, but it also rewards the terms which appear more number of times in the same uh, you know uh, same document. For example, A and C. A and C best explains this. C and A both appear in three documents, but C appears only one time in these documents, whereas A appear two times. So according to it, A is more important than C, but A is less important than H because A is appearing three documents, while H is appearing in one documents. So this is how we calculate the TF-IDF term. So this is not all. So I'm going to do a quick fun exercise to let's see like if these values, which two values are more similar, or which two term or languages are more similar based on this TF-IDF. So I'm going to use cosine similarity to calculate that, but before that I'll have to convert it into Python in right format. So I'm going to quickly split them and play around with them a bit. So basically, if I split them first on new line character, then split them on tab. Okay, I should see something like unexpected intent, but where? Okay, here. File list attribute has no split. Okay, my bad. So first we'll split these lines, so it will look like something this. Then we'll split on tab characters for line in this line dot split \tab. Now we have list of list. Then what we are going to also do, dot strip, and also dot replace these term with 0. List object, why list object is not okay? We have splitted it. Okay, my bad. There is so much pre-processing just to convert. I could have saved in a CSV file and then loaded, but that's fine. For val in this, for each val we are going to just, now what? Okay, it is saying so once it replace it, we'll convert these into float. Okay, now we have our data ready. So as you can see, okay, now we have list of lists. So let me print in better format. So we have this data ready, TF-IDF. Now we are going to calculate, see, cosine similarities equal to cosine. I've already loaded cosine. Okay, cosine is not defined. I thought it is loaded. What is happening? Maybe some excitement of what the results look like. Okay, now we have, okay, so basically let me also bring the language. Okay, so basically first one is Python. So similarity of Python, so similarity of Python with Python will always be 1. Okay, but similarity between Python, Java, C, JavaScript and Scala. Okay, so Python has 0 similarity with Java, C and Scala, but Python has 0.14 similarity with JavaScript. Okay, then if we look at Java is highly similar to JavaScript, and you know why? Because Java, the prefix is same, only the script part is different. Okay, so JavaScript is similar to Java. Okay, no, third one is for C. C is similar to like 0.12, similar to Java, and very less similar to JavaScript. Then for Scala is this one. It is similar to Java, it is similar to C, maybe because C is appearing here. It is also similar to JavaScript. So this makes highest similarities between Java and JavaScript, which we also know because these two are very similar terms. So that is all for this particular TF-IDF tutorial. I will come up with more tutorial using TF-IDF in clustering and so on, and using some sentence data, or something like that. So that is all for today. Thank you so much. If you have any if you have any questions or anything, just share them with me on comments. Okay, thank you so much. Bye bye.